Okay, so in this video we're going to have a look at a circle exam question from the 2020 paper 2. So we see here we totally have a circle C. There's the equation. My equation is in the form GF and C. Point A is the centre. That's been marked. The line L is a tangent to C at the point T. So there's my line L, tangent at the point T, and it's tangent to my circle C. Point B, 5,8 is on L, so there's B, and find the distance BT. So they want us to find the distance from this point to this point. So first thing I'm going to do is, when I see that distance there, I know because I have my tangent, the angle formed is 45 degrees, and then, or 90 degrees, sorry. I'm going to join A and B together, and it forms a right angle triangle. And my goal here is going to be Pythagoras. So while it presents as a circle question, really, and maybe a line question to some extent, really it's more so a trig question, in the sense that we need to find these two sides in order to get our unknown sign. So we'll be using our distance formula twice. First thing we want to do is find my coordinates for A, the centre, which we can do from our circle equation. Get the distance from the centre to the point B. That will be our easiest one to do first. And then we don't need to worry about the coordinates of T, because we can use our circle equation to figure out the radius. And if I have the length of the radius, then that's my distance from A to T. So if I have this side and this side, I have two of my three sides, and I can use Pythagoras to find the third side. So first thing we'll do is figure out our centre. So we have the equation circle x squared plus y squared minus 4x plus 2y minus 4 equals 0. And we know centre is equal to minus g minus f. And the radius is the square root of g squared plus f squared minus c. Minus 4x will equal 2gx. Drop the x's, minus 4 equals 2g, divide both sides by 2, and g equals minus 2. 2y is equal to 2fy. We can drop the y's. 2 equals 2f, divide both sides by 2, and f is equal to 1. So then my centre is going to equal minus g, so that's 2 minus f, which is minus 1. Radius will equal the square root of g squared plus f squared minus c. And again, just for c, be careful with your signs. So if the c value itself is a minus, then that will cancel and give us a plus. Whole thing into the calculator. Minus 2 under square root, minus 2 squared plus 1 squared minus minus 4. So the radius is equal to 3. So we can fill 3 in on our diagram. We've now found our coordinates of A, and my next thing to do is get the distance from A to B. So now we're looking at equation of a line, distance formula, so that's the square root of x2 minus x1 squared plus y2 minus y1 squared. The centre we know is 2 minus 1, and the coordinates of B is 5,8. We have x1, y1, x2, y2, so the distance will be 5 minus 2 squared plus 8 minus minus 1 squared. All into the calculator and just watch your signs. 5 root 5 minus 2 squared plus 8 minus minus 1 squared will give me back 3 root 10. It's just a quick sketch then of the triangle itself, just to simplify the shapes we're dealing with. We have a measurement of 3 root 10, and they've asked us to find x. We have, that was labelled A, B, and T. So now it's just Pythagoras. A squared equals B squared plus C squared. A is equal to 3 root 10, B is equal to 3, and C we don't know. So we get 90 is equal to 9 plus x squared. 90 minus 9 is equal to x squared. X squared equals 81. So then x is equal to root 81. We get back x equals 9. And originally then it wasn't called x, it was called bt. So we have bt is equal to 9 units. Or you can just leave it at 9. But safest to put in units when we don't know our unit of measurement. So that's that question answered. Again, presents as a circle question, but really it's maybe a combination of the line and Pythagoras' theorem. The only circle part we needed initially was to figure out the center and figure out the radius, but with any circle question anyway, they should always be your first two steps. Okay, and that's us done.